So can we now go to page 2 of notes 14B and draw my load line? X-axis is what? VCE. Y-axis is what? IC. Where they two intersect, 0. Draw your load line. Cut off here, how much? 12. Saturation is how much?
120 million?
120 million. Okay, so there's my load line for this circuit. Let's now find, we did the saturation test, right? On page 1 of 14B, 3.2 meg greater than 220K. Okay, let's go to page 2 of notes 14B. VB. VB is R2 over R1 plus R2 times VCC. Voltage divider. R1, 10K. R2, how much? 22K. Here we go. 22K over 10K plus 22K times 12 volts. You know what? This circuit that we're analyzing here is the same as the circuit that we're going to build in the lab. The only difference is we've got 10 volts for VCC in the lab. Here we're doing the analysis with 12 volts. So you can use these notes for your lab analysis. Okay? How much? 8.25? Okay, anybody disagree? Let's now find VE. VE is what? The voltage at the emitter to ground. So is that VB minus what? 1.4. This is also mentioned on the back page under Appendix 5, Darlington pair common selector amplifier circuit, DC analysis, total current gain, beta total is beta 1 times beta 2. And VE is VB minus 2 times VBE. The base to emitter of the first transistor, base to emitter of the second transistor. So it's VB minus 2 times VBE, 8.25 minus 1.4. How much? 6.85. Okay, so that's VE. That's this voltage here. I use this voltage to find IE, which is IC. So that's the logic. What we're trying to do is find the Q point here. Is it here, here, here? We don't know. So in order to find the Q point, I need to find the VCE value and I need to find an IC value. To find the IC value, I start at VB, then I find VE, and then I find IE, and that IE is approximately equal to IC, which is my Q point. So that's a 3-step process. So IE is VE over RE. VE is how much? 6.85. RE is how much? 100. What's 6.85 divided by 100? 68.5 milliamps. So that's one of my Q points. Now that I found IE, I can say that IC is approximately equal to IE, which is 68.5 million. Which is one of my key points. Make sense? Now that I found IC, I can find VCE. VCE is the voltage from the collector to the emitter from here to here, which is total voltage minus what? The voltage at the emitter. So that's VCC minus VE. Everybody see that? So is that 12 minus 6.85? How much? 5.15. So that's my second Q point. I just found my Q point, which is what DC analysis is all about. The DC analysis of a transistor circuit is finding its Q point, its operating point. Is it near the middle of the load line? Is it close to cutoff? Is it close to saturation? These are the things you'd like to know when you're working with a transistor circuit. If you're using a transistor for digital circuits, let's say you suddenly are putting your digital circuits cap on your head. Now you're thinking about cutoff and saturation. Is the transistor open or closed? Open, closed. 0, 1. 0, 1. But with electronic circuits, we'd like to be somewhere in the middle. Okay, so where's 5.15 here? Halfway is how much? 6? So where's 5.15? Just on the other side? Can you write down 5.15? Go up and across. And that's your 68.5. Make sense? So that's the Q point. Now let's do AC analysis.